So for our topic 4 challenge, the problem we are trying to solve is which cone and fins will have the least air resistance so the rocket can go the highest, and we will need to compensate for forces such as gravity and air resistance would be basically friction.
The constraints we'll have to follow are materials, which are we'll have to use cardboard, masking tape. We can use a glue gun with one stick of glue and 2 pieces of copper paper. We also are able to bring in one material of our own if we want to, and we have to create it in 25 minutes.
So for topic 4 challenge for the water rocket, what we're going to do is it's just a simple water rocket design. We're going to be using a little cone, like most people, just so the air can just flow off a little easier. It just goes straight through. And then the fins let off even more air resistance from the air that came off, so it can just go straight. Yeah. So that's basically it.
Oh my god.
We determined the height of our launch, which was 3.43 seconds, and plugged it into the formula d is equal to 1/2 gt squared to get our height of 14.7 meters. Before launch, the rocket received elastic energy from the launcher to gain kinetic energy when going through the air, and then at max height it had all gravitational energy, with some dissipated caused by the air resistance. And after this, it had gained speed, which gave it kinetic energy, and by the time the rocket had hit the ground and stopped moving, all the energy was dissipated. When the rocket lost all of its water, it still had some gravitational energy, about 1.3 joules. This was because that it lost all of its water really quickly, but there was still, it took a little bit of time for it to lose its water, so it was still had a little bit of height off the ground. And the rest of this energy was kinetic, since it had just launched, and there was probably a little bit of dissipated energy, but it was very little amount. The conservation of energy allowed us to give us pretty much approximate and close to accurate values on certain amounts of energy and certain kinds of energy that the rocket was experiencing at certain times, which allowed us to make these calculations with the formulas that we had. Energy was dissipated from air resistance from when the rocket gained speed and in the process of reaching its max height, and all of the energy had become dissipated by the time the rocket hit the ground and had stopped moving. If we could do this again and improve upon its design, we would add bigger fins so we could resist the air better to create the least amount of dissipated energy and give us more air time.